Hello, my mathematicians. Today we are looking at Module 6, Lesson 2, which is all about representing addition with different size parts. Hopefully, by the end of this lesson, you'll be able to represent the sum of fractions with different size parts using a visual model. So the spark you're learning says Julia runs through an obstacle course. She climbs a cargo net in 1/4 minute. Then she crosses a balance beam in 1/6 minute. How long does Julia take to complete both obstacles? Draw to show your reasoning. So we have 1/4 and we have 1/6. So we want to see what we can fit underneath both of those. Well, as we talked about yesterday, if we know the multiples of both of these, that can help us. So we think, we have 2 is not a multiple of 4 or 6. 3, not a multiple of 4 or 6. 4 is a multiple of 4, but not of 6. 5 is not a multiple of either one. 6 is a multiple of 6, but not of 4. 8 is not a multiple of either one. 10 is not a multiple of either one. 12 is a multiple of both. So we can drag our 12s over. And we can see how many fit underneath. So this would be our drawing. It would look like this. And we would have 1/4 plus 1/6, or 3/12 plus 2/12 would equal 3 plus 2 is 5/12. So it says, how long does Julia take to complete both obstacles? Well, the answer would be 5/12 of a minute. Go on to the next page. Okay, so it says some obstacle courses include a rope climb. On his first try, Travis climbs 2/3 of the length of the rope. On a second try, he climbs more than his first try by 1/6 of the length of the rope. What part of the rope does Travis climb on a second try? So this is complete the fraction model to solve the problem. Draw to show your thinking. Well, how can we split this up? Well, let's first look at our choices. Is 3 a multiple of 3 and 6? Well, it's a multiple of 3, not a multiple of 6. Is 6 a multiple of 3 or 6? Yeah, it's a multiple of both. So we can split this in 6. So we have 1/6, 1/6, 1/6, 1/6, 1/6. It says one student used all 1/6 strips fraction strips to find the part of the rope Travis climbed on his second try. Another student used all 1/12 fraction strips. Who is correct and how do you know? Well, we used all 1/6, so we know that's right. But what about 1/12? Well, if we split the 1/6 in half, that would be 1/12. And if we did that to all of them, we would get an equivalent fraction. So that works. So both students are correct. The part of the rope Travis climbed on his second try can be represented by 5/1/6 fraction strips or 10/1/12 fraction strips. So then we go to question B. Could you use only thirds to represent the sum? Explain. No, thirds are too large to represent. One sixth. It says write an equation to model our solution. Well, we started with 2/3. And we're adding 1/6. So now we have 5/6. So what part of the rope does Travis climb on a second try? Well, he climbs 5/6 of the rope. And then we go to the next page. Okay. So it says to make the obstacle course more challenging, the swinging rings are moved 1/2 foot further apart. They were 5/8 foot apart. How far apart are the rings now? How does the new distance between the rings compare to the length of 1 foot? Well, so if you think about it, we have this is 1/2 of a foot, and 5/8 it's more than 1/2 of a foot because 1/2 of 8 is 4, so it's going to be greater than 1. So the new distance is greater than 1 foot. Since 1/2 plus 1/2 equals 1, and 5/8 is greater than 1/2. So now it says draw a visual model to represent the situation. So we are going to start with showing the 1 since we were asked to compare to that. And we are going to have 5/8. So we're going to go 1, 2, 3, 4, 5/8. And then we are going to add the 1/2. And so we can see that there's a gap there. It's greater than 1. But we need to figure out what we can fit underneath both of these. So we need to think about multiples. So it has to at least be the 8ths or more in order to be a multiple. So yeah, let's just start with 8. Is 8 a multiple of both 8 and 2? And it is. So we know we have 1, 2, 3, 4, and 5. And then we fill it under the 1/2 to get our answer there. Put this in. And it says, how far apart are the rings now? How do you know? Well, we got a total of 9/8 right here. So there are 9/8 feet apart. Or we can simplify that. We know we have 1 whole 8th, or 1 full foot, and then 1/8 left over, as we can see here. So, or 1 and 1/8 feet apart. And we know this because our visual model shows 9 1/8 fraction strips. So that is all for today's lesson. I hope that you are now able to represent the sum of fractions with different size parts using a visual model. And as always, remember, in order to be a math person, you just have to be a person and do math.